Hello, everyone. My name is Aranza Duarte, and today I will be talking about data analysis using grid computing. So, first of all, let's start by defining the concept. What is grid computing? The word grid is basically used to describe the ability to share information technology resources in a global environment in such a way where it is much simpler to access to a variety of hardware and software resources. Grid computing is generally a nonprofit organization, which means it has its own volunteers, and it can be defined as a computer network where each of the computer's resources are shared between the rest of the devices involved in the system. So, how grid computing works is that one main computer distributes information to the rest of the interconnected computers present in the system. Talking about a specific scenario using grid computing could be this one that is in the screen, which is HPE launches world's first solar-powered supercomputer Hikari to solve the Zika virus. The reason why I chose this scenario is because it just occurred like 2 months ago, so it is very recent and also very interesting. What happened in this scenario was that the company HPE joined forces with a variety of organizations, such as the Texas Advanced Computing Center, um, the New Energy and Industrial Technology Development Organization, and also NTT Facilities to build what claims to be the world's first solar powered supercomputer, and they named it Hikari. The reason why they built this computer was to calculate biology applications that would help solve the Zika virus crisis. When these companies teamed up, they wanted to ensure that Hikari did not require the huge amount of energy traditional supercomputers usually require, so they decided to build this computer using solar panels. The way it works is that the solar panels are wired directly to the computer, meaning that it runs on free energy in the most efficient and sustainable way. Since traditional supercomputers produce a huge amount of heat, the companies decided to use a warm water cooling system named Apollo 8000 that eliminated the need for computer room air handlers. How this supercomputer works is that during the day, all of the energy that is produced by the solar system fits straight into the computer, and at night, when the photovoltaic array does not create energy, the Apollo 8000 system is switched to an AC based grid. The social and ethical issues present in this scenario were security and people and machines. First of all, security refers to the protection of hardware, software, machines, and networks from unauthorized access. So, one major security risk with grid computing in this case would be that if an attacker hacks into the system, he would be able to have access to all the data that is stored in the grid, which would be confidential information, and this would be very dangerous. The attack can take various forms, but the most common one is a DDoS attack, which stands for Distributed Denial of Service Attack. The other issue would be people and machines. People and machines refers to the use of IT systems, bringing a very significant advantage to the people using them. So, in this scenario, the technology of the supercomputer Hikari is helping not just one, but a huge amount of people because all of the discoveries and solutions found for the cure of the Zika virus crisis will be shared with the rest of the population and will give them hope to overcome the disease. Applications to specific scenarios, I chose health because in this case, HPE in the case of HPE, grid computing is employed to share all the information about the Zika virus crisis between a number of companies, such as the one I mentioned before. So the use of grid computing in this situation is really beneficial, not just for one company, but for all of them, because together it makes possible to solve the large and complex problem about the Zika virus and it enables companies to collaborate globally with other companies to find the best solutions for this virus. The IT systems present in this scenario are HPE, TACC, NEDO, entity facilities, which are all of the organizations involved in the system, and of course the Hikari supercomputer. Defining the concepts, first of all, we have supercomputers, grid computing, and network. Supercomputers are used for highly calculation intensive tasks, such as problems like the weather forecast, climate research, molecular modeling, and physical simulations. Grid computing, as I said a couple of slides ago, is a term referring to the combination of computer resources from multiple administrative domains to reach a common goal. And network is defined as a series of points or nodes interconnected by communication paths for the purpose of transmitting, receiving, and exchanging data and voice and video traffic. Some problems that may arise from the use of grid computing in this scenario would be that an interception of the resources would be very dangerous. The attack can be done in various forms, such as DDoS attacks, like I mentioned before, and the interception of data in the grid can cause the attackers to use it for evil purposes. So this would create negative impacts instead of positive ones. And since in this scenario all the data is related to the virus and people's health, the misusage of data will cause serious problems. Stakeholders are defined as the people or organizations who can affect or can be affected by another organization's actions or policies. So, in this scenario, the main stakeholders would be the scientific laboratories and the people who work in them. By having as a competition a new supercomputer, in this case Hikari, who is working on biology applications to help solve the Zika virus crisis, the laboratories would consider this computer as a threat to their investigations, since this technology is much more supported and advanced than the rest. And also, all the scientists working in the laboratories could have the risk of losing their jobs. Some feasible solutions to this problem would be that by having a DDoS attack, you could make a system to protect all of your grids from any type of attacks. So this system would detect the abnormal network characteristics caused by DDoS attacks by using statistical methods and the cumulative sum algorithm. So if the attacker uses spoofed source IP addresses in the attacking packets to avoid traceback. So they apply the statistic method to detect the abnormal changes of new IP addresses when networks are attacked. They actually have done a simulation of these experiments before, and they proved that this system can detect DDoS attacks quickly. So even though more work towards realizing the secure grid computing still needs to be done, this system can be a feasible solution to prevent the interception of information. Using grid computing, there is a lot of people out there, attackers, who want to intercept and to have all of this data. So by actually having your system protected, even though a DDoS attack would occur by hackers of the rest of the people out there towards your system or towards your computer, all of the information would be protected since this attack would be detected so fast. And well, that is all. Thank you very much. And I hope you liked the presentation and it can help you. And right now you can understand in a much better way what is the concept of grid computing and all of the problems that may arise, those social and ethical issues present, and how it can be a benefit to a variety of people and organizations. Thank you.